Without further ado, I'd like to introduce Kirsty Manliklik, who's here with us from the EPA's WaterSense program. Recently, he worked on the EPA's label program for low-embodied carbon construction materials. Prior to that, he was the program manager for the EPA's Green Chill Partnership Program. And he holds a PhD in environmental engineering from the University of California, Irvine.
Well, thank you for the intro, Chris. As always, WaterSense appreciates you and the Energy Star staff for the logistics to make this webinar series happen. I am elated to give two introductions. First off, we have Holly Cannon. Holly is an environmental scientist with over a decade of experience promoting water efficiency and sustainable facilities management. In particular for WaterSense, she has helped to develop technical materials to assist the commercial and institutional sector in implementing water-saving best management practices. She assists with the product specification development process for the program and supports the WaterSense labeled homes program. She has also completed more than 30 water assessments of federal facilities and helped us, EPA, reduce our potable water use by over 40% from a 2007 baseline across the facilities that we own. Simply put, she's supported the program for a number of years and is a frequent presenter on this webinar series. Also joining us to illustrate how advanced metering infrastructure, again, AMI, data can result in water savings in the real world is Dave Wallenstein from East Bay Municipal Utility District headquartered out of Oakland, California. East Bay MUD was with us for our August restrooms webinar. Awesome to have them again. Dave is a licensed mechanical and civil engineer and has been with East Bay MUD for 25 years. In the last 20 years, Dave has worked on a number of metering, advanced metering infrastructure pilot projects, water loss control, and water conservation projects. Dave has also worked in East Bay MUD's operations, seismic improvement program, and water supply improvement program. He holds degrees in mechanical and civil engineering from UC Berkeley and Cal Poly San Luis Obispo. In case this is your first time joining us, our webinars are part of a monthly series that Energy Star and us, WaterSense, co-host together to encourage water efficiency within commercial and institutional facilities. This year, we've held 7 webinars, with today being our 8th and final for the year, covering a wide range of topics in water efficiency as it pertains to the commercial and institutional facilities space. These include how O&M changes can improve your water use, irrigation changes and practices, retrofit and capital improvements, restrooms, and several others that you see here. Recordings of these webinars are available on the Energy Star website. After today, we are excitedly lining up speakers and planning our webinars for next year, so no pun intended, stay tuned. And really on that note, I most assuredly know that there are great innovative water saving stories out there. If you'd like to go from being in the audience to being a speaker, please reach out. We'd really love to hear it. Honestly, the more the merrier. Whether you share for 5 minutes or 25 minutes, your engagement in WaterSense really brings value to everyone. So just some run of the show. We'll spend some time covering the basics of WaterSense and advanced metering infrastructure. We'll also discuss how facility managers can use AMI data to save water and utility costs. Then Dave will cover a variety of awesome success stories illustrating how he and his team at East Bay MUD use AMI data to identify and fix large leaks and water waste. And after that, we'll review steps you can take to get started using AMI data now, and we'll use the remaining time for a live Q&A. Just in case we have some new folks tuning in, and again, hopefully we do. We want to grow that WaterSense community. WaterSense is a voluntary program that was launched by EPA in 2006. The program works to promote water efficiency so that we can help organizations and consumers save water for today and for the future. The WaterSense label, which you can see here, gives just a simple way for consumers and businesses to identify water-efficient products, programs, practices, and homes. And products earning the WaterSense label have been independently certified for water efficiency and performance. The label is reserved for products that reduce water use by at least 20%. And again, and here's the key point, they have to perform as well or better than standard models. There is a good variety of residential and commercial products eligible for the WaterSense label that can be used in commercial and institutional facilities. Over 45,000 product models have earned the WaterSense label in the 8 different categories you see here under indoor plumbing and irrigation products. And of course, our website has plenty more information on how each of these products can save a facility water. We also work closely with our co-hosts, our Energy Star colleagues here in the building, to include water factors in their specifications. And conversely, we consider energy savings in ours. For example, Energy Star certified clothes washers, dishwashers, ice machines, and combination ovens are all also water efficient when compared to standard models. We even collaborate beyond just specifications. For example, EPA has a water score for multifamily buildings supported through Energy Star's Portfolio Manager tool. In addition to labeling products, homes, and professional certification programs that help save water and helping Energy Star include water efficiency criteria in their specifications, WaterSense also develops a bunch of technical tools and resources to assist those interested in reducing their water use. For commercial and institutional facilities, WaterSense has developed many technical tools and resources to help with conducting a water assessment, creating a water balance, or otherwise understanding water use and water efficiency opportunities within different building types. EPA keeps all of our resources for commercial facilities on the commercial tools and training section of the WaterSense website. This section of our website houses technical guidebooks, assessment tools, worksheets, checklists, case studies, and links to recorded or other upcoming live trainings. And of course, you can always reach out to us if you need further assistance and support. Our most comprehensive resource for commercial and institutional facility managers is the WaterSense at Work guidebook. WaterSense at Work is a compendium of best management practices meant to help commercial and institutional facilities understand, manage, and reduce water use. To help facility managers get started, it includes best management practices covering water management planning and water use monitoring, including a chapter on metering and sub-metering, which touches on the advanced metering infrastructure topic that we're focusing on today. It also has fixture or system-specific BMPs for sanitary fixtures and equipment, commercial kitchen equipment, outdoor water use, mechanical systems, laboratory and medical equipment, and much more. If you identify potential leaks or water losses at your facility, these best management practices can also help you figure out how to fix and eliminate your unintended water use. WaterSense is frequently updated, and we also welcome any feedback on it that stakeholders may have. Now I'll go ahead and hand it over to Holly, who will introduce you to AMI and how you can use it to help your facility reduce water use.
Thanks so much, Kersey, and welcome everyone who's here today. I'll quickly touch on what AMI is, and then I'm going to hand the show over to Dave, who has some boots on the ground experience. So here's a graphic showing what is AMI. And AMI is a collection of devices and systems used by water utilities to collect, measure, communicate, and analyze water use data. Using AMI, water use data is collected from the meter multiple times per day, often hourly and sometimes even more frequently than that. The data is sent via signal all the way to the water utility where they can see a facility's hourly or more frequent data and identify water use patterns. Some utilities have online customer portals or smartphone applications that allow users to see the collected water use data and the resulting trends as well. And some utilities provide details on water use data on your regular water bill or include a more detailed report with your water bill. We'll mostly be talking today about how facility managers can use AMI data to better operate and manage their portfolio, but AMI also offers a host of benefits to water utilities that I want to mention in case we have any utilities here on the call who haven't yet deployed AMI in their service areas. Utilities can better serve their customers, target and monitor water conservation programs, detect and measure water losses, and redirect time and resources spent reading meters to other projects, just to name a few. So what does AMI provide? The chart on the left illustrates daily water use patterns from one facility, and the chart on the right shows hourly water use patterns from another. As you can see, since water use data is collected frequently, the AMI system is able to differentiate to some degree the end uses of water. So typical indoor water use here is colored blue, and that's called normal use. AMI can also identify possible leaks or continuous water use, colored orange, and it can differentiate timed irrigation events, which are colored in green. AMI portals allow at least the utility to see the water use data at the most frequent interval and also see patterns and trends across other time intervals, such as daily, monthly, or annually. Utilities and facilities, if they have access to this level of data, can determine if the water use trends and patterns are typical and expected, or if the potential leaks identified are actually wasting water and money. Some of the reasons to try and access and use this AMI data are obvious. If you're able to identify leaks or otherwise unexpected water use and fix them, you can save water and money. And end uses that use hot water, like a stuck steam boiler bleed valve, also use energy. So if you find and fix leaks there, you'll save even more money in utility cost. Similarly, AMI can help facilities avoid surprise water bills. The image on this slide shows how an AMI system is projecting future water use for a facility based on historic patterns. Many facility managers only see their water use on a monthly or even quarterly basis when the bill comes in, and sometimes only the finance department of your facility is seeing that bill. So facility staff aren't able to see the water use trends and identify problems or project future consumption. But AMI data can allow a facility manager to check water use almost in real time and make changes before the bill increases. Many customer portals allow the user to set alerts if a certain amount of water is exceeded or if a leak is suspected, and that can be super helpful in identifying issues. Commercial water damage is common and it can be very costly. So beyond the cost of the wasted water, floors, walls, ceilings, equipment, even foundations may need to be repaired in the event of a large water leak. Flooding can also damage electrical equipment and lead to other safety hazards if gray or black water are part of the leak, and there can be mold growth. So fixing these types of things can result in operational downtime, and using AMI data to detect these issues right away, fix them right away before they become these massive crises can really be beneficial. Facility managers can use AMI data to estimate and report savings to executive management and get buy-in for efficiency projects. Promoting these data-based decisions for water conservation can really help demonstrate an initiative's value. Referencing AMI data can help identify leaky toilets, failing irrigation systems, old water-cooled air conditioning units, so facility managers can perform preventative maintenance before there's any type of major issue with that equipment. And AMI data can also help accurately track water use data and target water efficiency projects to help meet ESG or other sustainability goals, setting you up and demonstrating that you're a leader in sustainability. Meeting ESG goals, implementing these water efficiency projects, and otherwise committing to sustainable practices can help your business grow, and it also shows a positive impact on employee recruitment and retention. So lots of benefits. And you probably now want to access that data. So there are several ways a facility may be able to access AMI data. It really depends what the utility offers, and I don't think I've said it yet, but not all utilities offer AMI. But many do. So the first step is to reach out to your water utility and ask whether advanced meters are already installed at your facility and how you can access that data. Many AMI utility programs include an online customer portal that provides access to the meter data. This can be integrated into your billing system, so you may need to ask your billing department for access. Customer portals sometimes include information on local incentive or rebate programs, watering restrictions, conservation tips, and resources for finding and fixing leaks. Many of these portals allow customers to set notifications via call, text, or email when water use hits a certain rate or when the system identifies a potential leak, leak being defined as a minimum amount of continuous use or a sharp increase in use. And some systems require the user to opt into these. They aren't always automatic, so be sure to look into this if you do have AMI. You may even be able to customize the leak alerts based on hitting a certain dollar or volume of water, and that can be really helpful to your facility if you're budgeting. If you have a normal continuous use as part of your operations, that can be the case in certain manufacturing or industrial facilities. You can override and customize those notification settings for leaks so you aren't being constantly alerted when your water use is actually as it should be. Some AMI systems offer smartphone apps to access the data and receive alert notifications. That can be really helpful for facility managers who often aren't sitting at their desk. They're walking around the facility. You can get a little ping when something seems off base. And if your water utility doesn't have a customer portal or an associated smartphone app yet, utility staff are generally willing to work with you and share data if they have AMI. So you might be able to work with them on a one-on-one basis to get information or for them to prepare a specific report to include in your water bill. So by analyzing more granular data, facility managers can begin to identify trends and patterns. So unexplained usage or anomalies to these trends could indicate leaks or other issues. For example, if the business has a general baseline use and the data shows a steady or a sudden increase, it could mean there's a small faucet leak or a leaky toilet flapper. There could be a cracked pipe that started to spread, or even a stuck cooling tower makeup valve sending a ton of water down the drain. AMI data can also help look for other patterns, like when your irrigation system is running. This can help inform if your irrigation schedule needs to be adjusted or reduced, especially if the local utility has watering restrictions for a certain time or on certain days during periods of drought. Continuous uses and potential leaks should generally be investigated. In some cases, continuous use doesn't indicate a leak. For example, some equipment uses water continuously, like dipper wells, or medical equipment like kidney dialysis treatment. Sometimes continuous use is expected in the case of single pass cooling for ice machines, but AMI can really help you see exactly how much water is used, how much water is needed for that purpose, and sometimes it can even help justify swapping equipment like those single pass cooled ice machines with air cooled models. To make further use of your data, you could integrate your AMI data into Energy Star's Portfolio Manager tool in order to compare buildings within your portfolio to each other or compare similar facilities across the nation. And some AMI systems provide specialized data like water pressure, temperature, or water quality. Water quality can be really vital to an organization like in beverage manufacturing or for maintaining equipment that's prone to scaling like a cooling tower. It can also be good sometimes to identify if you have high or low water pressure that can impact some equipment's performance. So in general, AMI just offers great real-time feedback, quality data. It can help you identify issues and see results when repairs are made and when water efficiency projects are implemented. So it's a great resource for saving water and utility costs. This slide provides some resources on AMI. The WaterSense website includes a link to an AWWA guide for utilities on how to use AMI for water conservation, and the Alliance for Water Efficiency has other AMI resources for water utilities. Most of what I talked about today is covered in WaterSense's AMI guide for facility managers, and that guide also includes some case studies that I didn't go over today because our guest speaker, Dave Wallenstein, is going to present several case studies covering a variety of facility types in EBMUD's service area. His presentation offers, like I said, a more boots on the ground look at AMI, and we're really excited to have him here to present those case studies today. So I'll hand it over to you, Dave. Let's see, so I'm making you a presenter as discussed. All right. It's being passed to you, Dave.
All right.
Take it away.
Okay, thank you, Holly. I appreciate the background. As she said, my name is Dave Wallenstein. I'm an engineer with EBMUD. Why is this not going down? Okay, so today I'd like to talk to you about how we use our AMI system to help our customers reduce water usage at their facilities. I'd like to start with just a brief introduction of EBMUD and then talk about how we identify opportunities to save water using the AMI system, including fixing leaks. I will present some interesting case studies, which I hope will be useful to you. Our service area spans over 332 square miles in Alameda and Contra Costa County in the San Francisco Bay Area. From Crockett in the north down to San Lorenzo in the south, we provide 1.4 million customers with clean, reliable water. We also have over 740,000 wastewater customers in the western half of our service area. Hourly and daily consumption information from AMI offers new insights into how and when water is used that are unavailable with monthly meter reads. We also get some nifty algorithms that can identify usage types such as leaks and irrigation. AMI makes it easy to identify when a leak starts or grows and ensures that when we got it fixed, it stays fixed. So I wanted to start with a quick example. So we noticed a high spike in water usage in an office building, and we thought it should be investigated because it was in the middle of winter and no cooling towers should be running at that time. We had some difficulty in reaching the owners because it was a large corporation with no local numbers. Eventually, we just knocked on the door and talked to the security person. They referred us to a maintenance person who told us actually only a few people are still working in this building and the usage couldn't be real because he would see the water leaking somewhere. We immediately asked about the cooling tower, and he checked on it, and sure enough, the float valve was stuck open on the makeup water and was overflowing and dumping water to the drain where he didn't think it was going. Once he got up there, the leak stopped immediately, and the usage picked back up in the springtime when the cooling tower was back on. So questions to ask when you're looking at AMI data. We ask a number of questions and help determine if there might be unintentional usage or some kind of maybe a leak. We might walk our customers through these types of questions, such as what should the usage be? Or is it a 24-hour, is it a plant that operates 24 hours? What about weekends and holidays and seasons? Is the usage trending up over time or is it pretty flat? Did they have a history of leaks that might give us some idea? And as always, we look at the irrigation budget to make sure that looks appropriate. Oops. Sorry. So what are some typical leaks? We will work with a customer to go over the use of typical leaks and excess usages. Most of the time we find multiple issues, but irrigation is often the most common problem. Sometimes we can figure things out just over the phone, asking our usual list of questions. But often we have to go out to a site visit if the customer really needs some help or it's a particularly big leak. Sometimes these investigations are pretty interesting and of course fun. We learn something new each time. So stay tuned for some interesting case studies. So looking back at the usual suspects, Holly mentioned quite a few of them, but it's like a valve that's stuck open or equipment that's not operating correctly. It could be a broken pipe somewhere, or maybe a fountain that's running constantly, or maybe even human air. Often we'll look at the recirculating systems, the heating and cooling, because they may have unintentional blow-offs or things like that. And like I said, we always want to include irrigation. So let's talk about irrigation. Leaks in irrigation systems can be in many different areas. Irrigation is often scheduled when no one is around, so we don't see what's happening. So you want to check for leaks in many different areas, including from the meter to the backflow, from the backflow to the valves, the laterals to the heads. Look for broken heads, any kind of miscellaneous extra faucets or quick connects, and maybe even other water features that may be on there, like a fountain or a bathroom. So I put together a few case studies to help illustrate these points. So I'd like to start with what happened at a senior living center. This is an example of a very large multifamily building that is becoming much more prevalent in our urban areas. Because there is often only one meter, without AMI, it is sometimes very difficult to see what's going on and if usage is normal or can be reduced. In this case, our senior complex has about 300 dwelling units and roughly 3 1/3 people per dwelling unit, so about 1,000 residents. It's been fully occupied since 2022, so it is a fairly new building. But the usage, as you can see here, from January 22 to the present, has increased from 20,000 gallons a day to 71,000 gallons a day, which is about 71 gallons per day per capita, GPCD, which is a bit high, and we suspect there might be something going on. So let's look at the hourly and the daily data a little closer. It's very interesting. The hourly usage is shown on the top is very flat. And the ratio of maximum to minimum hourly is very low. People are using almost as much water at 2 o'clock in the morning as they are at 10 o'clock, and that looks suspicious. And looking at the daily usage, there's very little fluctuation, which may be expected for a senior living center, but I would expect to see some kind of pattern, holidays, weekends, something. Our algorithm recognizes that the continuous usage is a possible leak, so that's colored in the orange here. And we suspected there was something going on. So we went through the usual suspects of leaks within this building and successfully rolled out all but one of those common areas. I'll walk you through these. So we looked for leaking pipes. As it turned out, we were fortunate. All the piping was above ground. We thought, okay, then maybe there's a cooling tower. There was none. It's in Oakland, so it's cooler. We looked through the hot water and the boiler system, and we found some minor issues, a little air problems with some air bleed valves, but nothing that would explain what we're seeing on the data. We suspected, well, maybe they're tied into an irrigation system that has a problem. There was an irrigation system, but it was working well and it was on a different meter. Then we looked at common areas, offices, very little usage. We said, okay, well, what about the laundry, the dishwasher, any other appliances that the building might have? And there was no issues. There were some P-trap primers, which are pretty common in newer buildings. Basically, they dribble water into P-traps to keep the odors from the sewer from coming up. But that didn't turn out to be much, and we actually turned them off, and it didn't make any difference. What we did find were some issues with toilets, and I'll talk about those next. So the problem that we found is that most of the toilets at the center we inspected had unusually high tank levels. Of course, generally speaking, the higher the tank level, the more water is used in flushing, and thus perhaps they're getting slightly better performance from each toilet. However, as shown in this image, any slight vibration could cause water to spill into the overflow tube and basically waste it. So just by adjusting the toilet tank levels back to the recommended height, the center lowered their water usage from a high of 71,000 gallons per day to a new low of 34,000 gallons per day. We think we're getting closer to solving the problem by cutting the usage in half, but we still suspect something else might be going on. Now let's look at a material supply plant. So obviously what drew my attention to this account was the sudden jump in water usage at the end of May. It took some time to locate the appropriate personnel to shout out and say, what's going on? When we did reach them, they were totally unaware of the leak. And they said, hey, this is a 5-day-a-week, 10-hour-day operation. This doesn't make any sense. So pretty quickly after we got a hold of them, we asked them to just go out and take a look and see what they found. And this, next slide here. This is what they found. Here's a video and image of the leak that they found, which is in an above ground pipe in a kind of a remote area. It is running at about 80 gallons a minute. It turns out this pipe was above ground and no one noticed it, but they were able to repair it in this screen that same day. So the usage suddenly dropped. But let's look at the post-leak repair data. We see that they still have a baseline usage of about 14,000 gallons a day, 7 days a week. And some days are a little bit higher, but given the flow rate and the way they operate their on-site tank, we wouldn't expect there to be really any water usage on Sunday and a little bit on Saturday, maybe. But in fact, this never stops. When I look at the billing data, when I look at the AMI data, this baseline is the same all the way back to when we first installed the AMI there in 2019. And actually looking at the billing data, it goes back many years before. So even when the plant is completely valved off, we still see this, and we dug a little deeper. So we then began to consider there's a 1,200-foot pipe between the meter and where the plant is. It's above ground in many places and underground in others. We walked the line of the pipe and did not observe any additional leaks besides the one that was fixed. However, just listening on the pipe where it's above ground, we could hear the sound of a leaking pipe. We had our crews from EBMUD, as a courtesy, correlate this leak um, and at various different points where we had access, and pinpointed the location of the leak in this red X here, where the pipe was underground. And it had the highest leak noise there. And I don't know if, I apologize for the image. This is a field photo of the actual leak, but it's a pretty good correlation signal there. Unfortunately, this turned out to be a pretty difficult place to dig up. And so they're still trying to work on a solution for this. Now let's look at a large high school. I'm going to talk to you about how we wound up saving more than 50,000 gallons here at multiple locations. As you can see from the image, the high school has quite a few meters servicing different areas. Sometimes it's not that easy to identify which meter is serving which area. Sometimes we have to run water while looking at the meter to see what meter, run some water and see which meter starts rotating. Other times, if the meters are rotating, we'll turn off water valves until we see the meter stop. We then focus on which of our AMI meters are showing continuous use and begin the process of chasing down the leaks within each area. I'm going to walk you through some of the leaks that we identified. Let's start with this meter here. We noticed that one of the meters had increased usage in the last 5 or 6 years in our billing data. Looking at the available AMI data, we could clearly see that this was from a leak based on the continuous usage, which is nearly the same for 24/7, but it did appear to be increasing. From the we know for sure that at least since 2019, this leak had been going. We're not 100% sure what was happening before. So let's dig a little bit deeper into this. So here's what we did to find the 30,000 gallon leak that had been getting bigger and bigger over 5 years. First, we started at the meter. It's a compound meter, so we looked at both dials and turned off the various things and saw the meter still moving. Then we traced the pipes, and to our surprise, water was boiling up out of the ground. We then went into the basement and traced this pipe into the basement, and we saw water in the sump pump in a room filled with electrical equipment. We knew that something was going on. Looking around, we found that there was a pipe that was actually leaking in this crawl space in the basement. The leak, because repairing this leak would shut off the whole building, we had to wait until spring break to do a temporary repair here on this pipe. And then over the summer, they did a full system break. But as you can see, the water usage has gone from basically 30,000 gallons a day to 0 on the weekends, and then back to a normal weekly pattern during the week. And that's the normal pattern. A lot of this usage turned out to just be from a photo lab that used a lot of water. So let's now look at this meter that is servicing the ball field. This field had recently been converted to AstroTurf, so the high build usage was very strange. Our first assumption was that the pipe was somehow broken in the AstroTurf field. However, looking at the usage pattern, it seemed to be more cyclical than your average pipe break. In fact, the usage pattern seemed to be tied to weekend events at this high school. We determined that this higher use may have been from use of the bathrooms in the locker rooms, which of course were getting a lot of use when they had events. But they wound up hiring a leak detection company anyway, just to make sure the pipe wasn't leaking. And what they said is there's no noise, there's no sound of leaks on the pipe under there, but they do hear sounds coming from the bathroom. And there's some peaks after some field events. Sure enough, the leakage was actually happening in the bathrooms, not on the ball field. The flushometers in the bathroom were constantly running. Especially after a big event, we saw big spikes in usage followed by long leaks. It was determined that the diaphragms in the flushometers in these toilets and urinals had failed, and the school wound up replacing all 30 of them. Immediately after replacing those, the leak was stopped and the problem was solved. There is no other leak suspected on this meter. Let's do another one. Let's take a look at one of their irrigation meters to see what might be happening. This one happens to be an irrigation meter servicing a baseball field up in the upper right corner. So the green bars represent irrigation usage. This usage is much higher than the irrigation budget for this field. That was calculated for this area, and there does seem to be a lot of constant usage. So we decided to go ahead and do an audit just of this area, an irrigation audit. We went through our normal process, and when all was said and done, the problem turned out to be that one of the irrigation valves was stuck open. It turns out that the baseball coach had a habit of watering down the fields before games by manually opening the valves, but it turns out he was not as good at closing the valves. So here's one of my coworkers listening on the valve, and sure enough, it was running, and we were able to turn it off and stop the leak. But we did go through our usual techniques of reviewing the irrigation schedule, looking for wet spots, using acoustic techniques. We did a survey of all the property and identified maybe there's something else on there. Didn't find anything. We traced the pipes in the field so we could look for where the pipes were running for wet spots. And we ran each valve that's on this irrigation station just to make sure there was no pipe breaks or high usage. And we measured the flow rate that was on each station to see if it worked right. And it turns out it was just this one valve that couldn't be turned off. Well, now let's look at a large condo complex. This is another type of housing facility in our service area. For years, we've been working with this complex to try to help them save water. We primarily focused on irrigation issues, but over the years, we found various small leaks and the occasional pipe break. But looking at the AMI data, this distribution doesn't make sense for those kind of leaks, particularly not irrigation patterns. In fact, instead of looking like an irrigation pattern, this looks more like a heat wave. In this image, there is the normal red, small amount of leaks that are always going to be there. But the daily summer usage was so much higher than the winter. And in fact, it looked more, like I said, the temperature profile. And during the pandemic shelter in place, the usage got particularly high, especially on very hot days when people were locked inside. Irrigation did not explain these peaks. Some days, the usage even hit as high as 400,000 gallons a day on just 1 meter. And looking at the hourly usage in between January and August was also revealing. During the winter, the consumption matched a typical indoor cycle, where you have a little bit of usage at night and then more usage in the morning, maybe with some toilet leaks or things like that. However, the summer usage was not an irrigation. We don't expect people to be irrigating at 4 o'clock in the afternoon. In fact, it looked more like the temperature of the day. And so we decided to do an indoor audit, and we had 30 volunteers that offered to let us look through their condo units to see what we could figure out what this might be. What we found was, of course, the typical toilet leaks, a few faucet leaks, nothing too exciting. But it turns out that each apartment had individual water-cooled air conditioning units. These units use less energy than traditional air-cooled units, but what we found is that they were using a tremendous amount of water. Normally, the cooling water for these type of units would go to a cooling tower and be looped back. However, in this case, there was no cooling tower, and all the usage simply just ran down the drain. We ran one unit and measured the discharge at about 3 gallons a minute per house, per apartment. When temperatures soared in the East Bay, many residents would run these units from early afternoon into the evening. With everyone running their units simultaneously, the usage got incredible. This explained the huge spikes in water usage and the rivers of water that was running down the drain. The condo development agreed with us that this problem had to be fixed and wound up putting together a plan to replace every one of these water-cooled air conditioners with outside air-cooled condensers. This work is still underway, but here's a little bit about the project that's underway. First of all, the estimated water savings is 88 million gallons per year, or just on a daily average year-round, 78,000 gallons per day. There were 4 separate metered accounts, and just to give you an idea, the total usage on these accounts in August 2020 was 485,000 gallons a day, and in January it was 60. So that just gives you an idea of the impact of these air conditioners. It was about a $2 million project for this phase of the work, and it's about $4,000 per unit to replace the water cooled with these air cooled units. East Bay Mud offered a $60,000 rebate for this phase. We had to cap it at $125 per household. So now I wanted to offer some key takeaways from my talk. First of all, AMI provides an incredible insight into potential water savings that we never had before. We should focus on periods where there shouldn't be water usage and think about what the water usage should be during normal operations. Don't forget to check the irrigation system because sometimes the largest savings can be there. Fixing leaks can often be the fastest and easiest way to save water, but it's not the only way. It may take a lot of work, sometimes for us making multiple phone calls, but the potential savings can be huge. And when you solve the problem, continue to monitor your AMI data to make sure the problem doesn't come back. And if you fix the leak, it doesn't come back. And if you do an upgrade, that upgrade continues to save us water. And use automatic alerts. That was all I had today.
Thanks so much, Dave. Let me take back the presentation here. I really appreciate that, and having those real world examples is just so helpful to really conceptualize this data and this concept of using all this data. So really appreciate you sharing, and your key takeaways really jive with what I'm going to talk about on this slide. So it's really just what you can do right now. So you've attended this training. You know, once you sign off, what's your first step? And first, I recommend contacting your water utility to ask if you have AMI, to see how you can access your data. Remember that this also may involve coordinating with your billing department or whoever receives and pays for your water bills. Then, assuming you have AMI, if you haven't already, sign up for those leak alerts with your utility or through your AMI portal, so you're being notified when there is continuous use or another suspected leak. And then regularly monitor that AMI data and identify and fix leaks. And WaterSense at Work that Kirsty mentioned earlier, and also WaterSense's Fix a Leak Week webpage, both have information on how to fix a leak once you've identified it, how to operate and maintain all different types of water end uses, repairs, replacements, retrofits. That's all included in these resources. And there's also details in there to help you do a comprehensive assessment of your facility. If you aren't necessarily sure where the leak is coming from, they can really help you get to the bottom of that. And then once you feel like your water use is as it should be, your facility is operating efficiently and effectively, like Dave mentioned, use that AMI data to continue to monitor your water consumption, benchmark your facilities maybe against each other, try to, become more efficient in any way you can, and you can see progress on your water efficiency goals through that data. This slide provides contact information for Energy Star, our co-host, WaterSense, and then also me and Dave. So feel free to reach out after this webinar if we haven't answered any of the questions that you have. And with that, we left a good amount of time for questions, so I'm pleased with that. And Kirsty, I think, is going to lead us in some lively discussion. So I'll hand it back to Kirsty.
Thanks, Holly. Appreciate it. First off, thank you, Dave, Alan, for the 2 webinars that you guys did this year. And Holly, Chris, thanks again, for whom this webinar series would not be a reality. I do want to note that I think a few folks messaged us and we're unfortunately having some issues maybe seeing some of the slides in the later half of the presentation. We apologize for that. Please rest assured, we'll put a recording up as soon as possible. We're happy to resend over the slides, and want to make sure we do whatever it can to make sure you get the material. So with that, I think the first question that we got was, for the toilets in the senior complex, did you gain access to every single unit to modify the tank fill height? A challenge that is being faced is getting access to each unit in the housing buildings to investigate leaky toilets when leaks can be seen through AMI. Any advice or recommendations? I think, Alan, you had responded to this in the chat, but wanted to give you an opportunity to answer verbally for the whole audience.
Yeah, I mean, we face the same issues trying to find the correct person. As Dave mentioned, it's just putting the boots on the ground and calling, either calling or physically walking over to the location. But just trying to be the squeaky wheel and finding somebody who would actually care about the water use is just persistence on our part. Um, so it's calling and finding out who the property manager is, the building engineer, facilities person, whatever it may be, and getting that good contact info. And that always seems to change. So we're always, a lot of times we are trying to have to hunt down somebody new at a new leak that we find.
And I would like to add too that it did take the customers, in this case, building management is the one that did the toilet inspections, and it took them about a month just to gain access and coordinate. I'm not a landlord of the multifamily building. I don't know how it is, but they were able to. I mean, it took a long time. Luckily, the adjustments are quick. So, but they were very happy that they saw this steady decline with every toilet they adjusted.
Awesome. A second question that we got is, how do you go about identifying properties where these problems may occur? It seems obvious when looking at the data, but how do you know where to look?
I'll take that question. The software that we use allows us to identify leaks and that are active, and I will simply sort them by largest to smallest, and I'll start digging in. And in the case of the rock plant, that one popped up, and it kept popping up, and I kept trying to reach somebody. But basically, I'll look at the patterns. And like I said, I'll use my intuition without even talking to the customer. Does the pattern look like, does it look strange? Is there 24/7 operation? Is it a 24/7 operation? Is the usage increasing? And basically, once I make a phone call, I'll have an interface, a Teams meeting with the responsible party, and 90% of the time, the water usage is not the way it should be. Occasionally, we just chalk it up to that's just their operation, but it is a manual process. But when you're saving 50,000 gallons a time, it's worth it. 50,000 gallons per day, I mean,
All right.
Just
Go ahead, Alan. Sorry.
can I add to that?
Yeah.
Yeah, there was another leak which we found, and I actually would take my son to his high school practice, sports practice, and I could see water out in the street constantly coming out from underneath this apartment complex. And once we were able to get on site, we actually just walked the whole complex with their facilities guy, and I think we were in the garage and we found they showed us some sump pump area, and we found that water was chlorinated, and eventually that led to them finding out that their irrigation was on that same domestic water use meter, and they were leaking about 20,000 gallons a day, I believe, just from these 3 irrigation valves that were broken, and that nobody had ever noticed because all the water was draining into a subfloor on the mezzanine level and then being pumped out onto the street. And yeah,
And that ran for, I think, 7 years. Is that right, Ellen?
I think it was, yeah.
Yeah.
All right. We've got over 10 minutes, so let's keep the questions coming. Third one is, do you have AMI on fire services? Do you also identify water use outside of fire pump testing?
Full disclosure, we don't have AMI on every account in our service area. We only have it on some of the key ones and a lot of residential. But we do have some AMI on fire services, and I thought, wow, that's going to be a waste of money. But we have found leaks, that 1,000 or 3,000 gallon per day leaks on fire services, and customers that have inadvertently tied into their fire service, which is a no-no. So that does happen. I think I answered the question, but we don't, we're looking, when we decide to put a smart meter out there, typically we're looking for getting the biggest bang for the buck and trying to, fire services aren't of interest, but definitely it happens.
I believe the fourth question that we have is a challenge we're facing is residents aren't seeing this they aren't seeing AMI as a water conservation tool because they just look at the data showing more water usage rather than how can it help identify leaks and saving water. Do you have sort of a similar mindset issue in the Bay Area, and how did you get people on board with the accuracy of AMI and that it is contributing to water conservation?
Alan, I'll let you take that one. You work with the customers more.
Sorry, I was reading through the chat. Um,
I can take it if you want.
yeah, sorry, go ahead.
Yeah, so I don't think we're ever going to get 100% of our customers interested in saving water, but I think it depends on the customer and how the conversation goes. But I think it's important to emphasize that, as Holly mentioned, this is not just about money. This is about property protection. If you have water flowing 24/7, you would like to know where it's going. It could just be going down the toilet, but I've had so many people tell me they had $30,000 in property damage from a hardwood floor, a toilet that exploded or something happened, usually when they're on vacation. So I said, I sometimes when people don't want to hear about money or saving money, they think I said, I don't care about money, just want to protect your property.
I guess I can add to that for those that are concerned about money, we are able to, well, first of all, they are pretty skeptical of us when we call and tell them that they have a leak or that we suspect there's a leak. They usually attribute it to increased occupancy or they don't realize that we actually do have a smart meter out there and are able to see their water usage per hour, and don't realize that about 100 people shouldn't be showering at like 3 o'clock in the morning in one apartment complex. So it's just that it takes some time convincing them that from our expertise, like of why we think it's a leak.
All right, the next question that I'm seeing is, do you see water leaks on backflows? And it's the second part to this question. Don't know if you're allowed to answer it, but the second part is, are your commercial backflows customer owned or utility owned? And totally fine if that is not able to be answered.
I'll answer the first part, which is we have seen leaks on backflows. I just personally, I don't necessarily work on the backflow program. But Alan, do you know about who owns the backflow? I
I
think it's the
don't.
customer.
I
I
think
believe
it's
it's
the
the
customer.
customer.
I
But
know
we
that
do
we test them.
yeah, we do a certification program every year. So I apologize, it's not our area of expertise, but
Okay, we still got more time, so I'm going to keep it going. Dave, Alan, based on your experience, has there ever been, kind of, I don't know, equipment issues or whatnot, that has led to things like a gap in the data?
every day. Yes, and sometimes those are hard to explain. If a car is parked on a radio, we might lose some data, and sometimes,
Interesting.
unfortunately, a little bit too much inside baseball, but sometimes if you have a really big leak, the size of the consumption temporarily overwhelms the radio's ability to backhaul. So we'll lose data until that's adjusted, and we have a algorithm that can adjust the size of the resolution in order to. But in the days before that adjustment is made, we will lose a little bit of data, and we'll have to go back in and like read the meter reads to try and recompile what happened. But that does happen, unfortunately, and it's always a difficult conversation to explain to a customer why we don't have data, especially when they have this massive leak. So yeah, I've even had it where the leak itself covered the radio in water. We lost transmission. So, yeah.
Okay, so the next question I'm seeing, I don't. This one may not necessarily be particular to AMI, but maybe how Dave, you and Alan and East Bay Mud use your AMI system. But um, does the way you operate your AMI system send you sort of like a daily list of accounts or customers flagged as leaks which you can then investigate. I wonder if that maybe depends on kind of the thresholds that you and your team pick, but if you want to elaborate.
I'll take that. Yes, we do get a daily report of who has a leak. We obviously can't call all the people that have leaks. We prioritize the ones that we haven't reached out to before. Our system does send email alerts and or text messages or even robocalls to customers that sign up for leak alerts. But some of the bigger ones, I think all of you or in utilities know that the leak alert's going to some office in accounting that might be in a different state. And so oftentimes we like to have like an on-site person signed up for leak alerts, and that's sort of tricky, especially because people's jobs do rotate. So some of the bigger leaks we will actually call directly and let our fingers do the walking and track down. Sometimes that can take months to reach the right person. A lot of voicemails but I think that answers the question. But we do look at that leak report and flag some of these bigger ones like the cooling tower that I pointed out and the rock supply. Nowhere do the people that are actually on the ground ever see the data unless we tell them about it.
All right. Again, appreciate all the questions coming in. I think some of these are a little more specific and we'll take offline, but the next one that I'm seeing is Dave Allen. It sounds like your AMI maybe was kind of targeted in its deployment. From what you're seeing with with other water utilities, is it more typical that a utility will select the locations for AMI deployment, or is it more typical that the customers will request it, maybe some combo that it organically happens?
We're kind of unique. Most of the meters that are on this larger were part of a special grant that we got from the Bureau of Reclamation to target larger customers, and then we've been taking advantage of those. Most utilities that I have worked with do just a full system, or they'll start with a pilot program and then do a full system. Because our system is so big, it's not a trivial job to convert everywhere. So we've been doing a lot of lessons learned, and we are just about to launch a new round of installations. But typically it's not, it's all of the above, but most people don't do it the way EBMUD does it. They just go for it. I think it's
Okay. From a utility perspective, do you all have a dedicated team or effort that really does the customer outreach, or is it more of a sort of, as we come across it kind of thing?
uh we have a really good water conservation staff, and many are involved in outreach to customers. I think we're refining our message. This is a lot to do for our one department. So I think we're still learning, to be honest with you. I think this just in the last few years we've been targeting these big high water issues, and so it's kind of we're sharing with you as we learn, I think is a good way to say it. But we have a really great team at EBMUD that people just not just in water conservation, but in the field that understand the importance of conservation.
All right. Well, in our last minute, there were still about 5 or so questions that we couldn't get to. Please rest assured, I'm going to circle back with Dave, Alan, and Holly, and we'll get back to everyone. Again, they were really more kind of detailed questions. With that, at the end of the webinar, you will get a survey. Please fill it out. It really helps us. It helps us and the Energy Star team kind of figure out which webinars are most effective for folks. So if you like what you saw in with this WaterSense webinar series, please fill out that survey. It helps keep us going. I want to thank the audience for joining us, and I'm sure AMI I think will continue to be a big topic. We plan to have it back again for next year. And with that, everyone take care, and we'll see you in the new year.
Thanks so much. Thanks, Kersey. Thanks, Dave. Thanks, Alan.
Holly, thanks, Kersey.
Yeah, thanks, all.